This is lesson 6.2a, multiplication and division of rational expressions in elementary algebra. Sorry about my voice. I lost it for a couple days and just now is it starting to come back. Anyway, what we're going to do is we're going to multiply rational expressions. So let's just look at example 1 and see what they've got there. And this is going to follow some rules that we've set up before. And those rules being, you look at one piece of this equation or this expression at a time. So what we do is we look at this piece, this one, and this one. And we simplify each one before we do anything else. Alright, so this right here is already simplified, so nothing is done there. We can't factor anything out, we can't reduce, we can't do anything. So I'll leave that one alone. So let's look at this top one here. I'm going to rewrite what we've got already that we're leaving alone. And we're going to change that x squared minus 9 because it's the difference of two squares to x plus 3 and x minus 3. Alright, and then we're going to look at the bottom. And at the bottom there's no exponents, but there is a 2 in front of the x and there is a 4. So I can factor out the 2 and be left with x minus 2. Alright, once that is done, then I can start going across my division signs. Now, one of the nice things about this multiplication sign here is that we can go across multiplication signs. I can see an x minus 2 here and cancel it with this x minus 2 here. Now, if this were a plus or a minus sign, you could not do that. But since it's multiplication, I can cancel that with that. Now, and again, the plus and minus signs lock these terms together. They cannot be separated. I can't cancel this x with this x. Because it's got a plus after it, or if it had a plus or a minus in front of it, everything is locked together. So all I can do is cancel exactly x minus 2, that's linked together, x minus 2, that's linked together. I've got to cancel the entire thing. Alright, same with the x plus 3 and the x plus 3. And that leaves me with what's left on top, x minus 3 over just the 2. Alright, so what I did then is I just multiplied those. Now, when you're given a division problem, it is done the exact same way, only there's one little additional step, which won't be too bad. So I've got a huge bunch of stuff here that I have to write down. And it says divide by x squared plus 2x minus 15 over x squared minus 25. Alright, so again, I do each part of the expression here separately, and then I can start canceling. But the one thing I do differently that I didn't do up here is there's a division sign. So what do you do when you are dividing fractions? Like that. You never divide fractions. You take 1/2, you turn it into a multiplication, you take that and you flip it over and then you multiply across. Same thing with these big expressions we have here. We're going to write the first one as is. So everything's going to stay the same. Times, and then we're going to flip the second one over. Just completely flip it over. And then you do the multiplication. Okay, so let's see if I can move a bunch of this junk up so I've got more room. Alright, so let's take this one here and simplify it. I'm going to factor out a 3 on the bottom. Two numbers multiplied together give me 20, added up give me negative 1. The negative right here means my largest number is negative, times difference of two squares. Okay, so that one's done. Now let's look at this one. Two numbers multiplied together give me 15, added together give me 2. 5 times 3 and I need to get a negative, so one of those has to be negative. Well, since this is positive, my biggest one has to be positive. So 5 minus 3 gives me my 2, and 5 times negative 3 gives me my negative 15. Okay, I've simplified everything. Now I go through and do the easy part, and that is canceling. X minus 5, x minus 5, x plus 5, x plus 5, and I'm left with 3 over x plus 4. And life is good again, because that's a pretty easy answer. Okay, well, let's just keep moving here, and we will continue with the fourth example. Okay, this is, I'm not sure what example this is. It doesn't say. It says example 1, 2, and this one just says examples. And then the next one says example 5. So, well, anyway, let's just do it. Okay, so we're going to factor out a 3. Okay, we're going to leave the a squared there. Can't do anything with it. Got that. We're going to factor out a 2. Alright, and then we cancel that and that. I've got 1a here and 2 here, so let's cancel one of these and cancel one of those, leaving us with 1. So on top I have 3, and on the bottom I have a 2 and an a, and I'm good. Alright, let's look at another one here. It says we're going to divide, and if you look in that examples part, I see what they did now. They have a 4, and they have divide x squared plus 7x plus 12 over x squared minus 16 divided by, I'm just going to flip it before I write it, just because I don't want to write it twice. It's a waste of good paper. Okay, so let's simplify this one. So I've got an x and an x. And let's see, multiply together, give me 12. Added, give me a 7. Okay, bottom is a difference of 2 squares. And factor out a 2. And see if I can factor that. Now notice, you could do completing the square, but they've pretty much made it easy just to factor it into 2 binomials, because they're mostly concerned with you being able to do that, and then being able to do the canceling like that. Let's see, what else can I do? Oh, I've got a 4 and a 4, so I have 2 over x plus 3, and that's it. Alright, let's look at a couple more examples here, and then we'll be done. So we're going to jump to example number 5. So we have x squared minus 49, and they want us to multiply that by x plus 4 over x plus 7. So actually this is over 1, right? So we have x plus 7, difference of 2 squares. And we end up with x minus 7, like that. And you're done there with 5. Alright, let's jump to example 6, and then we've got a couple other examples. So we'll do example 6 on the next video.